Some of you might have already joined Craig's Gresbrink's keynote talk that we had several hours ago. Craig is an Ignite champion, product owner at 24 Hour Fitness. Those of you who live in the United States should know this kind of large fitness club. And in his keynote presentation, Craig basically explained and laid out the whole kind of business problem, all the limitations they have, and Craig explained in high-level terms, let's see how the Ignite powered architecture looks like and how they were able actually to minimize costs to become more scalable and more performant. And also Craig kindly agreed to do a deep dive for all of us, because that architecture, if you want to build that architecture that deals with millions of subscribers, with millions of people who daily go to the fitness clubs, at least, yes, they used to go before the COVID, but right now the United States are reopening, and I think that we are soon will be on track, probably in a few months, and the fitness clubs will be full, will be packed by people. And that system, to design, maintain, and optimize that system, you need to be an expert in Apache Ignite. And as I said, Craig kindly agreed to come and to share kind of internal implementation details. He wants to share his wisdom and thoughts with all of you guys. So let me bring Craig on stage.
Thank you, Dennis. Can you hear me?
Absolutely. How are you doing?
Well, let me just share my screen. Definitely appreciated the intro.
No. You're welcome. You're welcome. People need to know the heroes.
All right. Well, as Dennis said, I did present a keynote this morning that gives a high level, and I have presented in the past, so you can see how we built up this system that I'm going to be discussing today. But today's pretty much a deep dive into 3 or 4 of the features of Ignite, and we'll actually be looking at some code. So a little bit deeper dive than I normally do in my previous presentations, but I think it's time. Again, I'm Craig Gresbrink. This 20 plus years. I've been a solutions architect for 10 years, and then I've been the Ignite product owner at 24 Hour Fitness for about 3.5 years. And for anybody who didn't see the keynote, we operate 280 health clubs coast to coast, and we've been doing so for 35 plus years. Like I talked about, we're going to do some deep dive into some features of Ignite. Those features are the continuous query framework, what it is, some use cases, some limitations, and then a limitation we solved with a service grid component, and we'll see some code on both of those. And then we'll talk about what Ignite Native Persistence or Ignite Persistence is and why we chose to use it and how it's enabled 24 Hour Fitness. And then lastly, we'll just talk about some of the SQL statements we run and the benefits of having a SQL-enabled cluster. One thing I wanted to say before I get into this presentation that I probably should have said in the keynote is you can think of what we're building as a data integration hub with I called it a converged database, but it's basically a digital integration hub or a data integration hub with data from a bunch of different systems. The other thing I wanted to say as it relates to the COVID-19 use case I presented in the keynote was that the way these billing systems work, if we would have just turned off billing and invoicing, billing is invoicing or billing and payment runs, that for 3 months or whenever the club opened, if we were just to do nothing but turn those off and then turn them on 3 months later, the systems are designed to say, oh, you haven't paid us for 3 months, but you've been active for 3 months. The systems don't know that our clubs are closed, so they would go and invoice you for the previous 3 months and then bill you for the previous 3 months. So that's all the work we had to do by querying Ignite and creating files and ingesting those to our billing system to prevent it from billing people while the clubs were closed. I don't know if I made it that clear in that presentation, but I just wanted to say that for anybody who happens to watch both of these presentations. And what we have on the screen is our high-level architecture at 24-Hour Fitness. We have clients, UIs. It could be third-party vendors through an API gateway calling our web services that we expose through the ESB. And then we have data services, which we kind of describe as CRUD services or queries of specific data. Those are also web services that our ESB calls. And then our ESB can call out to SaaS services. We're going to talk about our billing system implementation a little bit, as I did in the keynote. But we probably have 3 or 4, maybe 5 vendor or SaaS solutions that we call their APIs. Yeah, so our data services mostly, especially if we're talking billing system data, query our Ignite cluster running SQL queries. And some of them do query, you'll see on the bottom right, traditional relational databases. And then we have cache loaders that go and get the data from our vendor systems, and they'll do puts into the grid. So we can do queries from our data services. And then we'll get in a lot of detail about Ignite continuous queries, which you see on the bottom right. So just know we use those. Hey, look at that. There we are, continuous queries. I didn't lie. I started off thinking of continuous queries as sort of database triggers, something that can detect a change to a row or a cache or an object, and then do something with it. So you can think of it that way. You can think of it as a mechanism to do change data capture, which is basically when something changes, go ahead and determine if you care about that and then do something to your external systems. It's probably a better way because in our case with all these vendor systems around, or even some of our custom built systems, one change to a piece of data can cause changes to 2 or 3 systems to keep all the data in sync. And then on the bottom, we have Ignite's definition from their website of what continuous query is. And they get a little bit into their implementation of, or how they implemented this change data capture. But it's good to note that they have a concept of initial query that gets run when you first deploy your continuous query. And we'll talk about the deployment and how it works with some diagrams and look at some code. And then they have a remote filter that gets registered on the server nodes. And that remote filter calls out to what I call a local listener handler or a local listener. And we'll see diagrams on that. And then from there, you can do whatever you want. At least for us, you're in Java code. So a diagram of one, this is a particular use case that I think is semi-easy to understand, or the easiest one that's not specific to 24-hour. But we have on the bottom middle, we have a member migration listener, WAR. We do everything with WARs. That's our pipeline for deployment. And I think you can do continuous queries with just a jar if you wanted, but our pipeline's WARs. So this member migration basically is, I remember I said we have a new SaaS billing system, and we went in the keynote, we got rid of our on-prem ERP. And when we did that, we had to migrate data or migrate customers or members, as we call them, from our old system to our new system. And when we do that, it means we create an account in the billing system on the top right, and our data fetchers and cache loaders create an account in the grid, in the account cache, every 15 minutes. And when that happens, we have registered a remote filter on the server nodes that ask, oh, and we have a new account. Is that account's migration date not null? Why do we put that check in? Because that means it's a migrated member. If we didn't put that conditional check on the remote filter, then any new sales that we did in any of the clubs would also create an account, and we would fire on that. That remote filter calls out to the local listener that sits for us on a single JVM listener tier, we call it. And you can see that in the bottom middle where we deploy that member migration listener WAR. And that gets the event with old and new values on the account. In this case, that's not that pertinent because it's a brand new account, but we'll get into another use case where it is important to note that you do have access to the old and new values, much like you would in a database trigger. One thing that's on the diagram on the bottom right, at least in our implementation and what we found, we like to have multiple JVMs in a tier. So we'd like to have multiple listener JVMs in case one crashed, or if we want to do maintenance on those JVMs or VMs. But right now, if we were to do that, it would register a second remote filter and we'd get duplicate events, or we'd get notified twice in each of the 2 JVMs that a single account was created. So our solution to that was just have one JVM to have one notification per account. And I'll get into some of a possible solution on that GridGain or Ignite could have that to get around that. But that means if you take down that JVM, then you need to rely on the initial query. In our environment, we're event-driven architecture, so we detect the migrated account, we put it on our JMS system, and then our ESB consumes that. And we put that data in, we migrate the data and we create the member in our CRM system, and we go ahead and create the 2 caches you see in that data fabric box, the enrollment cache so they can check into the club, and the club of access, which gives them additional clubs they can go get into above and beyond their club of access membership. And so we get that from our old databases that you see on the top left, the member check-in databases. So we're pulling data from relational databases and putting it in the grid. And I think it's important to know, as we're looking at this diagram, this is an example of 2 caches, the enrollment cache and the club of access cache. Sure, we initially migrate it, but on any new sales, we're also populating those caches for a given customer or an account. The grid or Ignite is our system of record for the enrollment cache and the club of access cache. Though that data does not exist anywhere else. It is the system of record. Whereas our billing data, the account and such, the system of record is the SaaS billing system on the top right. Well, before I get into that, I want to make sure that I mentioned, we deploy the member migration war to that listener tier, and part of the framework deploys that remote filter, in our case, to the 7 server nodes or the 7 Ignite nodes that you see in the data fabric. So that's how, so we don't really have to touch the 7 Ignite server nodes. Fit clients in that listener tier or in that member migration war do the deployment of the remote filter for us. I did want to mention, when you undeploy that war, you shut down that JVM, it will remove the remote filter from the server nodes, again, necessitating the need for the initial query. Now we'll jump into some code. We are looking at member account delegate, or part of that member migration war. And this is, we're seeing the continuous query framework on the account cache. And this is the remote filter that's going to get registered. That will register with the server nodes this Java code. And like the diagram said, you can see that it's looking for accounts that are created. On line 111, you can see it's checking to see that the member migration, the migration date is not null. And then if you return true, that means propagate this event or this old and new values for your cache, propagate that to your local listener handler tier. If you say return false, like you see on 115, then you're saying it's a no-op. I'm in Java code. I know the data changed from the continuous query remote filter framework, but I don't care about it. I don't want to propagate it to my other system. And you might want to, you have choices on where you put that kind of conditional logic. We prefer to do in the remote filter as much as we can on the old and new values of a given object. Theoretically, you could query other caches and do anything you wanted in this Java code. We prefer not to burden our server nodes with that extra work. We would like to delegate that to that listener tier. But I think you could go either way, and it depends on the load on your system and how you want to operate and the volume of change you're getting to. So now we're getting into some Java code for the local listener. And again, this is the part of the continuous query framework that will get activated when you return true from the remote filter that sits on the server nodes. And we do some similar checks in here. We will check again that the migration date is null, but we could also do other checks. We're in Java code. We can query back to other caches if we want. We could query another relational database. We can make a web service call if that's what we wanted to do in that JVM and decide to propagate it even further. which is what you see on, let's see, it looks like line 128. We're propagating it to our JMS system. We're creating an event message on our JMS system saying we want to do something with this. This is another spot where you could have additional continual logic and decide to do a no op and not do anything about it. And again, notice here that we have access to the old and new values. That's important. You'll see lines 123 and 124. We can get access to the old and new values, much like a database trigger. So what's the initial query for? I kind of mentioned it. If you undeploy or there's no local listeners for your remote filter will be unregistered from the server nodes. I guess I'll say it this way. It does not work this way, but a request from the community or for GridGain would be to have an optional configuration that would allow the remote filters to batch up the changes that it wants to send to a local listener, such that you could take the local listener down. The remote filter would stay and just keep track of those changes. And when a local listener comes back up, propagate them. At least for us, I can see scenarios where you wouldn't need this initial query. And that'll become clearer why I would say that when we talk about some of the limitations in a particular use case where we had to rely on Service Grid to get around the fact that the initial queries don't have access to the old and new values. So again, this query runs if we were to bounce the VM or the JVM, undeploy that member migration war and redeploy it. And I think a key thing is, notice that I'm doing the same logic in the query on line 16 and 17 that I'm doing in the Java code. So by having the initial query framework this way, and I could take that out. Somebody could argue just take that out. But then for us, at least in this use case, the result set of this query is going to become much, much larger. So that's one thing that's a little unfortunate. If we change the Java code logic conditionals, we also have to make sure to change the query, or we might introduce a bug or a discrepancy. I wanted to point out here, since it'll relate later in the presentation, notice that we base this on created date or all records after created date. And what do we pass? Mentioned it. If you see on line 131 in our local listeners, we always log the last account that the local listener, the last account's created date that the local listener fired on, such that if 5 minutes ago we shut down that JVM, let's say data was continuously streaming into the accounts, we would have the date of 5 minutes ago. And then when we started the initial query would run, and then we pass in on line 18 that date of 5 minutes ago to get all records we didn't process, or all records since the remote filter was undeployed from the server nodes. Yeah, this is the actual initial query Java code. I showed you the actual query. That was like a query factory that you see on line 141. But here's the rest of the code that gets on line 143, gets that date I was talking about, the last time the remote filter ran. And then on 144, we set that as an argument on the query we just looked at. And again, you'll see that there's separate code for the initial query handler. And that's kind of what we see on line 157. We do the same thing. We go ahead and put the message on JMS because we've already in the query determined that it's a migrated account, or the migration date's not null. Again, we could have put some of that logic in here, but we didn't. One thing to note, in this Java code for the initial query, you do not have access to the old and new values. It's just a query on the current state of the data. So what is Service Grid? This is Ignite's definition up here on the top, and they mention you can deploy arbitrary code to the servers. They can create custom counters, ID generators, and such. For us, we have a pretty necessary but simple used case, and it's very much like a database trigger. We just want to, every time a subscription object changes, we want to write to a subscription history table or cache. And so that's what you're seeing down on the bottom of the screen is the subscription history cache. I only listed, I think, looks like 3 or 4 of the fields. That cache, a subscription object has about 20 fields, or 30 fields, and every one of them we capture the old and new values of that subscription. So we can see the first row in the output, we can see that that particular subscription object, its old external status was terminated and it stayed terminated. So it was previously terminated. And that's the key. One of our use cases we care about, subscriptions going from like the second and third rows in that table. If it goes from cancel pending to terminated, we need to fire upon that. That means contact the customer and thank them for their subscription. It can mean updating other systems. And with our continuous query framework, looking only at the subscription, we couldn't tell if it had actually transitioned to terminated. It looks, all we can really see is the new external status. So you'll see in the diagram how we use this new table to get around the fact that the continuous query framework does not have access to the old and new values of the object. But before I do that, this picture is from the Ignite Web Console, and you can see when you deploy a continuous query component, you'll see it in the services section. I believe it's on the monitoring tab. And you can see that we deployed a subscription history CQ class. We have 7 server nodes. That's why there's 7, and we only put 1 per node to write to this new cache. So here's a diagram of what I said. Hopefully hearing it twice and seeing the diagram will make it a little clearer. But very similar on the bottom left, the subscription listener tier, we deploy a subscription war, which does the things in 3.1, 3.2, and 3.3, just like that member migration. But in addition, we also deploy the subscription history CQ service war. And what it does, and we'll see some code on this, is deploys a service grid component that you see in the Data Fabric Ignite. And we just saw the data, the subscription history CQ service, and it does puts into that subscription history cache, namely whenever a subscription is created or updated. And then a key point on this, I kind of alluded to it, is notice on 3.1, it says initial query against subscription history. Our initial implementation of this was to do an initial query against the subscription table. But if you remember that row 1 on this table, if you do that, you don't have access to the old and new values. So you'll trigger on row 1, and you've probably already triggered on row 1 before because that subscription was previously terminated. So that can create problems when you consume that event and do things to your system. Like imagine emailing your customer twice that, hey, thank you for your business. Sorry to see you're canceling your subscription. You don't really want to do that. The rest of this diagram is very similar. See if there's anything worth noting. I guess this use case, why we care, up on the top, the ESB calling our data services, we circle back and we undo their check-in enrollments if it's a Club of Access subscription. So when a subscription terminates, under certain scenarios, we consume that event and we clean up data in our systems that would no longer be needed. So here's what the Java code looks like for the service grid. It's a little confusing because we actually implemented the service grid with continuous query, and I'll describe how it's different, but looking at code, but just to say that component stays on the server node no matter what we do to the listener tier. It'll undeploy, it'll stay deployed on the server nodes until you manually undeploy it. We'll see some code on that. Let's see. I think the key thing on here is that we go ahead and initialize this and deploy the subscription history CQ via this code. And it has a local handler. Let's see, on line 62, you'll see set local listener. On the previous member migration, it went back to the listener tier, the setting local and this local listener calling the handle. This is the handle events you see on 64. We'll look at that method. That method is a private private method in this subscription history CQ class, and that's what makes it the local listener call back basically to itself or stay on the server node. You might look at it that way. Again, this is the handle method, and it's just like any other CQ, except for it stays on the server node. And I'll go quick on this, but basically we're just getting the old and new values, populating a subscription history object. And then you'll see on line 203, we just do a put to the grid of the subscription. And that's what persists the data that we saw on that Ignite web console screen. So how do you deploy that thing to the server node? I showed a WAR that we do deploy to a listener. That is what causes the subscription history CQ to be class to be deployed to the server nodes. And that's what we're seeing. Where's that sucker at? Yeah, you can see it on line 32. We take that subscription history CQ and we deploy that to the server nodes, and then via the continuous query framework. I wanted to show something else. I think I've mentioned it. Yeah, this slide. What makes this a service grid component? If you see the import on the top right, that implements service, that's what gives you access to some of these service grid methods because you're implementing them. And that's what makes it a service grid component. Deploy on in this diagram. Real quick, I just wanted to note, I mentioned that that component will sit on the server nodes. A service grid component will sit on the server nodes until you do something to undeploy it. We've exposed this cancel service method on line 37 as a web service, so we can go undeploy that subscription history CQ if we would like to. Presumably, we might undeploy it and redeploy it with an additional field or more logic or some change to the subscription history CQ class. Switching gears a little bit, native persistence or Ignite persistence, or sometimes I refer to it just to capture both of them as Ignite native persistence. I'll let you guys read this and I'll just describe it. But essentially, if you do not have Ignite native persistence enabled, then all of your data sits in RAM or sits in memory. And you can only have as much data in your cluster as you have RAM or memory. The other significance would be if you were to shut down all of your server nodes, in our case 7 of them, maybe for maintenance, a maintenance window, or maybe they crash. If that were to happen, when you bring them all back up, you now have 0 data in your grid. You have to write external loaders or hydrate your grid with some external code. Ignite native persistence is the reverse of that. Everything, it's still memory first. Everything put in memory will be written to disk. And the significance of that is you can have more data in your cluster, and we'll see some numbers on that at the end of this presentation, more data in your cluster than you have RAM. The other significance is if you shut down all your server nodes, in our case, again, all 7, for a maintenance window, let's say, or a crash, you shut them down and you bring them back up, they immediately have all the data that they had when you shut them down. So that's a key feature. Let's see if I missed anything. Yeah, it's commonly called spillover to disk if you have more data than your memory can hold. And then a key point on number 1, so far we've had a lot of success. Ignite keeps the hot data or the most recent used data in memory, and you'll see our statistics of how much data we have in memory and how much we have on disk. But so far we haven't noticed any performance detriments to having a fair amount of our data on disk. So what was our reason for using persistence or native persistence? Well, as I mentioned before, we're putting all of our SaaS billing data or billing system data, plus we're putting other systems data like SIAM I mentioned in the keynote, into our grid. And sure, day 1 when we piloted this, maybe a year and a half ago, there wasn't that much data, but now there's a lot of data. And it's not clear to me, one, that we could, if we lost all the data or had to rehydrate the grid, it's not clear to me that we could, in a timely manner, query our SaaS billing system and get all that data and do puts into our grid. Certainly it would be hours. I'm not sure if it would be days. So day one, when we started implementing the billing system, we knew, well, let me take this opportunity to say, we implemented all this with the help of Grid Gain Professional Services. And it was actually when we started building this out, they're like, you know what you actually need? We got to turn this on. And that made sense to me. So we collaborated and said, yep, we definitely need that. So that's how we started using Ignite Persistence. I mentioned on a previous slide that 2 of our caches, it's really 8 of them, and I assume that'll grow over time. The grid is our system of record. That data does not exist anywhere else. So in any kind of corruption or shutting it down, if we had all the data in memory, it would be lost. So once you enable Ignite Persistence, you can consider making your grid an in-memory database or making it the system of record for some of your caches, which is exactly what we've done. And again, we have 8 caches that are, the grid is the system of record, and I suspect that will grow over time. One thing I want to say, that note on the bottom, it's individual, but for us, we use the Ultimate Edition because it has capabilities, data protection capabilities, backup and recovery. So once you start going down, you start using the system as an in-memory database and the system of record, then you might quickly find that you need data protection capabilities, just as you would have probably in any of your other databases. I wanted to show a little bit about SQL, at least how we do it. You can enable it. I believe you can annotate your POJOs. So this, what I'm showing is our subscription cache that we looked at with all those fields that were writing the subscription history. But I'm showing how we SQL enable the subscription cache. You can do it in Java code. You can do it, I believe, in POJO annotations. We choose to do it in XML, and that's what we're seeing here. I didn't list all the fields, but you can see it's like on 1808, line 1808, you see the opportunity close date, QT, that's a field on the object or an attribute on the object. And by convention, we expose every attribute on the object like this so that can be SQL queried. And that helps in debugging, that helps in new use cases come from our business. The developers writing the queries in their data services, they don't have to go back to this stage and go, oh, how do I query this field? So having said that, one question that comes to mind is, well, aren't you incurring a lot of additional storage by SQL enabling all these query entities or every attribute of your subscription object? And the answer to that is no. You're already storing the object with all of its attributes. So whatever's on the object, it's an object store. Ignite's an object store. So you're incurring the storage already. By making it queryable, you're just annotating it and letting the SQL engine access those object entities. So there's no additional storage. Now we get into indexes. If you're going to SQL enable your grid and use it to replace traditional databases like we've done, then you're going to want indexes. Previous presentations go into a lot more detail, but what we're seeing here is we index by our standard, or what we've learned, the primary key. So the subscription cache has an ID, and we index that. We index foreign keys in database terms or relationships, and a subscription's a child of an account, so it has an account ID, and we index that. Same thing with invoice owner ID. And then our third thing out of four possible, I should say, the 3 things we always do are the primary key, foreign key, and the natural keys, maybe like a social security number. But in our case, a subscription name is the code or the subscription identifier that groups all like records together. It's a natural key for the subscription. So the fourth one is optional. We don't always index dates. That's dependent on if we're actually going to put the date in the query. If you remember that initial query that I showed that was based on the subscription's create date, which is not shown here, but the subscriptions, oh no, it was the accounts create date. It said greater than, that account create date would be indexed because the initial query needs to use the index. Otherwise, you're going to do a full table scan. Same with this one. We create an index for the subscription end date because subscriptions have end dates, not all of them, but some of them. And when we have cron jobs or nightly jobs that look and see, oh, did any subscriptions end today? If they did, I need to terminate them and I need to inform or make data changes to other systems. So that's why that subscription end date is indexed. I mentioned that exposing columns does not incur storage, but you may have already guessed this. Creating indexes does cause additional storage. The system does have to keep an index. Lastly, kind of a gotcha that we'll get into. Notice the inline size of 45. I have a slide on it, but if you don't specify that inline size on your string columns when you create the index, GridGain, possibly unbeknownst to you, or Ignite, possibly unbeknownst to you, the default is 10, meaning it'll index the first 10 characters of your string. That caught me off guard. I don't recall having to do that in other relational databases or even contemplate that, but we had to drop all of our indexes and recreate them, and I'll explain why in a minute. Well, look at that. There's the next slide. I'm not sure why GridGain chose 10 or Ignite chose 10, but my guess is if you look at the bottom right, a lot of like Oracle sequence generators or a sequence generated ID, they're probably not much more than 10 characters. If you look at GUIDs, which we're using a lot of SaaS and vendor solutions, and they all seem to have GUIDs, this GUID you're seeing on the left are 45 characters. And if you notice, the first 10 characters of the two GUIDs I showed, they're identical. So you have to extrapolate that out with large volumes of data, 150 million objects or so, and growing for us. The more data you have, the more collisions you get on those GUIDs. So that's why we noticed some of our queries started taking longer and longer. And also it's dependent on, how would you say, it's not all queries against this particular object if this is our subscription. It's when you match up the first 10 and you end up getting a lot of subscription records back. So it's a little bit, I don't know how to say it, but not every query starts slowing down. Just it's data dependent. That's what I want to say. It's data dependent. And so we did start seeing it slowing down. We worked with GridGain support and they said, what are your inline index sizes? And we said, what are my what? And then I'm trying to prevent you guys, if you SQL enable your grid, please make sure you're setting on string columns, make sure you're setting your inline index length appropriately, probably to the max length of your string. You could do less if you care about storage, but for us, we want to index the entire string. And again, I've mentioned it a lot, even in the keynote, and I'll mention it here. This is a pretty tame query for us. So six caches or tables that we join and we're 99% of what we do is data services running queries like this. And like I said, this is a pretty tame one. It's just easy to show for a presentation, but we have a lot of other ones that have more sub-selects than this. This just has one sub-select. We have some that do unions. Some of them we affectionately refer to as mega queries because they get so long. But just know that the SQL engine can support a lot of joins against a lot of data and perform very well. I promised I would mention this. I've alluded to it, and I mentioned it in the keynote, a lot of the things that we had to do to adjust billing while our clubs were closed. And my last presentation was way back in October 2019. We were not in all of our 218 clubs with our SaaS billing system, but now we are. And now we've done a lot of the COVID billing updates that I mentioned previously. And our data has grown quite a bit. And one thing I want to note is we're only listing, I'm listing here 5 caches, but We have 64 caches in production. Those 64 caches represent 1.9 terabytes of data, and our seven Ignite server nodes, those sum up to 295 gigabytes of memory. So in that Ignite native persistence example, the rest of it, 1.9 terabytes minus 300 gigabytes, that's all being written to disk and is not in memory, and 300 gigabytes is in memory. So we are definitely spilling over. And some of these caches we're looking at have well over 150 million objects or rows at this point in time. So I just share that it's performing very well. Our data has grown in the last year and a half tremendously, 25 times more data than we had in 2019. And following the standards I presented on indexing and inline index size and such, we haven't had to do anything tuning to the grid. We haven't given the server nodes more CPU. We haven't given them more memory. We haven't added more server nodes. What we did have to do with our data growth because of Ignite persistence is add more disk to the cluster when we were doing all the billing adjustments, but that's to be expected. We created a lot more data. So some key takeaways. Some of this is from previous presentations, but sometimes Ignite's just used as a key value store. It can definitely do that. It can do JCache puts and gets. That's maybe how it started, at least for us and others who are watching. But it also can be SQL enabled, and it can be the system of record, and it can eliminate traditional databases if you want to jump into the deep end, which we have. And it can perform very well. Doing that can get you around API limitations, rate limits, maybe lack of capability that I presented of doing like searches. Most vendor systems don't really give you APIs that allow for that capability. So those are some of the reasons why you might consider creating this data integration hub or digital integration hub and a converged database on Ignite to really future-proof your company. And so again, it's a highly performant, fault-tolerant, clustered, converged in-memory database. I want to thank you for taking your time with me today. And I mentioned it a few times, but if you want the full story on how some of the details and the gotchas we hit along the way, on the screen are some previous presentations I've done of in 2017, it was like, what were we going to do? In 2019, it was like, here's what we did, but we haven't rolled it out to all of our clubs. And then now we're in 2021. We've utilized Ignite and created a tremendous amount of data in it, and it's performing very well.